coming, everyone. And welcome to day one of employee orientation at Ivory Tower Innovation Technology. We're super happy to have you here, and we all think you made a great choice joining the team. As you've probably heard in the media, a lot of people call us IT. As you'll come to appreciate, we don't care much for redundancy, so we just call ourselves IT. I'm here to talk to you a little bit about our engineering culture, and what we like to say is that our code has it. Yeah, we've really bought into it. We got t-shirts and everything. What that means to us is we follow the old adage. Right? When we're writing code, we make it work. Right? And to us, that means ensuring we have appropriate test coverage. To us, appropriate test coverage is full test coverage. We have 100% test coverage on every line of code that's written in all of our applications. So congratulations, no longer do you have to worry about if you're making a change to the system if you introduce a regression, because the test suite will have your back. But it's not enough to make it work. We also make it right. We follow all the latest and greatest best practices, but one that's near and dear to our hearts is writing dry code. We aggressively abstract away any duplication that exists in our system, so you only have to worry about making a change in one place at one time. We don't just make it right, we also make it fast. Performance is a first-class citizen here at Ivory Tower, and we make sure that we're writing code in the most performant way possible right out of the gate. We don't wait for a performance problem to introduce itself. We address it before it even becomes a thing. So as you leave orientation, go back to your teams, make sure to remember to make it work, make it right, and make it fast. Thank you all for being here. I think you made a really great choice joining the team. Give yourselves a round of applause. I really think you made a great choice. Great. Now I can show everyone at home that everyone clapped at my presentation, and they won't know why. I'm not going to give up. I'm not going to continue this charade for another 37 minutes and 30 seconds. My name's Kevin Murphy. I work at the NAR Company. We're a software consultancy in Boston, Massachusetts. But today we're going to be talking about what it might be like to work at Ivory Tower, or a company like it. I don't work there. I presume you don't either, because it's a place I made up. Everything I said in that beginning doesn't sound bad. In fact, they're all things that I like and I value in my code bases. But that sort of blind adherence to some of those structures can have some downsides or some unintended consequences that maybe don't get talked about as much. So today we're going to talk about them. So if we continue on our Ivory Tower journey and we wrap up orientation, we go back, we meet our team, everyone's super friendly. Our product owner says to us, I've got a great first problem to work on for you. We have a sign-up flow, and on that sign-up page, we have some testimonials that show up telling everyone how great our product is because we want them to sign up. And the number of testimonials changes based on different factors. And I noticed that today there should be 4, but we're only showing 3. Could you take a look at that? So you say sure, of course, what else are you going to say? And you're cloning the repo, and you're getting everything set up, and you're all super excited because you remember during your interview process, everyone was talking about how Ivory Tower uses only the latest and greatest technologies to make any sort of decisions. So you're wondering what sort of like crazy AI or machine learning you're going to get to throw at some data set to figure out how many testimonials to show how great this product is. And you finally find the piece of code that does it, and you're right to be excited. Ivory Tower is using the latest and greatest in predictive analysis. They have a big if test. Right? And you're looking at the bug, and all right, so it says there's supposed to be 4, so I guess Mercury's in retrograde, but I don't know. But like any developer, I have a stack of resources that I carry with me from desk to desk. And so I pull off the most important one, which is, of course, the Farmer's Almanac. It helps me every day. And it turns out Mercury actually is in retrograde. And today is the last day of the calendar year that we're going to see Mercury in retrograde. So we have some urgency here. We should really fix this today so we can make sure it actually works. Great. More pressure on day 1. But before we actually start to solve this problem, let's think back to orientation, right? Like, don't we have full test coverage? How is this even a problem? So maybe the coverage tool's broken? I don't know. So we look at the code coverage run, and that class is fully covered. And we find a test for this exact scenario. And it turns out that that test is stubbing some collaborator, some Mercury class, and we make sure that it is in retrograde, and then we new up a unit under test, and yeah, it's 4. Okay, so that's all well and good, but it seems like what we need to look at is that Mercury class, and that also has 100% test coverage. And there's only 3 lines, so let's skip the test and let's just look at the implementation. It's one class. You can ask it if it's in retrograde, pass in a date, and it's always false. And yeah, we have some test that executes that, and we have full test coverage. But we still have a bug, right? Because unfortunately, coverage doesn't give you the whole story. Coverage can tell you if you executed every line of code in your application, but it can't tell you if you executed every use case or business requirement that you need to satisfy in your system. And you may be looking at this and going like, this is a ridiculous example, and it is. That's part of the fun of making conference talks. Right? And you might be thinking, this would never, ever happen at my company. Right? Of course it wouldn't. We have a strong TDD culture. Right? We would have immediately written that test to make sure Mercury can report it's in retrograde, and we wouldn't have shipped this unless it was green. Or we do pair programming, and all of my coworkers are thoughtful and intelligent folks, and of course they would have noticed this and we would have solved it together. Maybe you run mutation testing on all of your changes, and you would have noticed that that date parameter isn't ever used in that method, so it wouldn't have passed mutation testing. We have a strong code review culture. Right? And again, similar to pair programming, someone would have caught that. It wouldn't have just happened. Maybe as the last stopgap, you have a QA team, right? And they're really good at their job. And part of their job is identifying all the test cases that your code can go through. And certainly they would have thought to test if Mercury can be in retrograde. And congratulations. Those are all great processes to have. I'm not against any of them. But if you're just looking at coverage to tell you if you have sufficiently tested your system, you're missing something. So let's look at something else that can occur when you're writing code in service of test coverage. We're starting to make changes to our system and making it so that we can actually tell you that Mercury isn't retrograde. And we're running the test locally, and one of them is failing some of the time. And it's not directly related to the changes we're making, but it's in the same class, so we're kind of nervous or concerned that we just don't understand the system. But we're not sure what's going on, so we sort of like give an awkward wave to the person that sits next to us, and they take their headphones off and walk over, and they're super nice, and you explain the situation, and they go, oh, yeah, that one? It just fails sometimes. Don't worry about it. And they go back to their desk. And you can take them at their word, but that's kind of bugging you. So you're seeing it's seeing if there's 0 or 1 testimonial, and we don't have the number 0 or 1 that shows up anywhere in this method, so I guess we're in this coin flip scenario, which is just generating a random number between 0 and 1. Cool. Let's look at the test that's giving us a hard time here. That description seems great. We're making some date, and we have some results array, and new up a unit under test, and then we move to that date, which is neither a Tuesday, nor a date where there's a full moon, nor a time when Mercury's in retrograde, so that we fall into the else condition. And then twice, we're asking for the number of testimonials and making sure we get 0 and 1 back. Which some of you are laughing because you've probably heard of probability. And this isn't going to be the case all of the time. So now you can fix this, right? You could say, like, well, the problem is we're running it twice. Let's just run it 200 times. And I mean, you didn't fix the problem. You made it less likely. But maybe you don't care about executing and seeing both 0 and 1. You can just say, like, let's just make sure it's only 0 and 1. And then if the regression suite ever throws a 3, then we'll fix it then. Right? And that's fine. But the issue was, this test existed at all in the way that it did, right? Like, there are any number of ways you can solve this problem, and This is not a talk on fixing flaky or non-deterministic tests. But the point is you had to do something because this test was written, and the reason it was written was because there was some need to test the random method in the Ruby standard library. Right. So I've maybe been a little unfair of code coverage, but to maybe rail on it a little more, is it something that really matters, right? Is it just a vanity metric that companies that have high code coverage like to trumpet about and make other companies feel bad about themselves? Like Ivory Tower has 100% test coverage and they still have bugs, so why do we care? Well, coverage is a signal, right? Unfortunately, we can't just throw it away. It gives you some information, but to figure out what to do with that information, you've got to dig a little deeper than just what the number is. So let's look at an example of some code coverage for a Rails application. If you're able to do so, you can see that all these numbers are in red, and red is bad. So obviously, every file in here is bad code coverage. But let's dig into this on a little deeper level. These first two files here are for Action Cable. They're Rails framework features. Doesn't really matter what it does. But if your application isn't using Action Cable, I hope this number is 0. Why are you testing something that you're not even using? Right? Maybe you have a good reason. I'm happy to talk afterwards if you do. And you could say, like, well, yeah, we should just tell our code coverage tool to ignore these files, or we should rip Action Cable out of our application. And those are reasonable choices. We could also just do nothing, and nothing bad will happen, I promise. Right. Similar story for these next two. There are other framework features. They're for background jobs and sending emails, and it may be the same story here, but you maybe introduced the first email into your system, and seeing this big 0 here is actually giving you some information. Maybe you want to test that mailer. This last one here is 80, and that's better than 0, but it's still red, so I guess we got to do something about it. But I don't know why it's wrong or bad. So let's dig into what the actual file is. You can see the 2 lines that aren't covered here are for a getter and a setter. And now if you have a lot of confidence in your test suite, you can make the argument that this is showing that you have dead code because this is never executed. And therefore, you can remove these methods. You have less code to maintain. Your code coverage goes up, and everyone's wins. And that may be the case, but you may also not live in that situation. Or maybe you know that there is part of your application that does use this method, and for whatever reason, you just don't have a test for it. And now it's not exactly a high cost to make a test for either of these, but you could potentially make the argument that I'm pretty confident in Ruby's ability to take a blob of data and assign it to a variable and then give it back to me when I ask for it. And if it didn't, there's probably a bigger problem in the world than my app. It's an argument you could make. I don't know how persuasive it is. But when I'm interested in looking at code coverage and how my tests are written in my application, what I'm more interested in is what the total cost of ownership of that test suite is. Right? Code coverage can help explain how far along you are in the path, but it can't tell you if all your tests are pulling their weight. One simple trick to increasing your code coverage is to write more tests. If you write more tests, you have more code, test code. And that's code that needs to be maintained and updated and upkept and continue working. And that is all great as long as it continues to be valuable. Unfortunately, that's a bit of a judgment call. If you write more tests, your entire test suite takes longer to run. Longer feedback cycles, both on CI and locally. As you write more tests, you may write a flaky test that fails sometimes. Then you need to make a choice. You either need to fix it, invest some time to figure it out, or you need to just ignore it. Right? Or you could delete it. And maybe that affects your code coverage, but maybe it makes your life a lot better. Because you don't have to wait twice as long to deploy to production anymore because you're just going to hit the rebuild button anyway. This talk, unfortunately, isn't about giving answers. It's about giving justifications for not doing work. Let's talk about another example at Ivory Tower. I've been working here for a couple weeks now. Things have been going really great. Ivory Tower is not a remote shop. And they have an open office plan because is there even another type of office anymore? And you're just diligently working at your desk, and off in the corner, some people start like cheering and celebrating, and I already said it was an open office, so immediately you're distracted and annoyed. You don't really know what's going on, so you give the same curious wave to your neighbor, and they give you a knowing glance. I'm so sorry, should have invited you to the Slack channel. Let me invite you right now. And it turns out there's actually some great news in there. Ivory Tower has decided to acquire one of their main competitors, Dark Dungeon. Now we're going to be working together. And we're going to be using the Ivory Tower code base because obviously it is the best. Now Ivory Tower and Dark Dungeon both have an API-based product, and they secure their APIs with an access key. And between Dark Dungeon and Ivory Tower, the structure of those access keys look a little different. And for whatever reason, decisions well beyond your pay grade is determined that as Dark Dungeon customers start to use the Ivory Tower code base, we're going to make new access keys for them, but they're going to keep looking like a Dark Dungeon access key. Sure. So we can do that. We've never worked on the part of the code base that generates access keys for, so we start by looking at some of the tests to get a sense of what this thing actually does. So we find this one test here that says that it doesn't make a company key. Sure. OK, cool. So we've got some class here that generates an access key, and here's how you make an access key. Just call this method and give it a couple parameters. And then I make sure that what I get back for a key doesn't look like this company regex thing. I'm assuming that company regex is a regex because it's called that, and I'm passing it to the match method. But I don't really know when I'm reading this test, and the reason I don't know is because this is just one test in a big test file that has a lot of tests, and the company regex is defined all the way at the top. And this is good because the company regex is used in a couple places in this test file, and we have chosen to not repeat ourselves. Now, when I'm writing tests, I'm a little more concerned about the readability and understanding of any of the individual test files. So instead, I prefer to write DAMP code, which stands for Descriptive and Meaningful Phrases. I did not coin this term, nor could I find out who did. So if you're in the audience, please stand up and take a bow. I apologize that I was unable to sufficiently research this information. And now, when you're writing dry code, it doesn't mean that your code isn't damp. However, if you're writing code purely in service of being dry, it may not be as damp as it could be. This test is one such example where we could just define the regex in the test file and use that regex. And now all we need to do is be able to read a regex. And that's hard enough, but it's really hard when it's 100 lines above. If we put all the context right here in this test, yes, we have some duplication in our code. Yes, if the company regex actually changes, we have to change it in 3 places. But we've given ourselves a lot more readability here. Time to stop screwing around with the test. We got actual work to do. We got to make those access keys look right. So we find the actual test file. Looks like, sorry, the implementation file looks like this. And we're sort of looking at it, and okay, I mean, it is what it is. Great. But we can solve this really quick, right? We'll add another parameter here at the method signature to say if it's for an acquired company. We'll default it to nil, so all our existing call sites will still continue to work. And then we'll just squish in another if test here and say if it's an acquired company, give them the Dark Dungeon format. Otherwise, keep doing what you're doing. And you may be reading this and you may have some problems with this. You may think this is all right. That's cool. But what does this have anything to do with dry code? Right? Nothing in here is repeated. So it's probably fine, right? Well, to talk about that, let's take a little walk down memory lane or look through the Git commit history for how this class even came to be and how it evolved over time. In the beginning, there was a user class, and there still is because it's a web app, and we want people to use it. Users needed to have access keys, and so they needed a way to generate an access key. So there was a method to allow a user to be able to do that, and everything worked great. And then later on, Ivory Tower started selling some enterprise clients, and they had their own unique needs and wants. And one of them was that they didn't want their access keys tied to particular users because users were employees, and employees did nefarious things like leave companies. And they didn't want their access keys tied to actual people. And now Ivory Tower could have just made a bot account for them or something, but for whatever reason they decided to say, great, we already modeled the company in our system anyway, so we're also going to give them a way to make an access key. And that'll be fine. And so author coded this up, put it up for review, and one enterprising developer that looks a lot like me but isn't made a comment and says, I have some additional context here. We're doing the exact same thing in the user class. We can extract this into one place, and then we only have to worry about it in one place. And the author thought that was a decent idea, and so the access key generator class was born. And both users and companies used it. And it was great, because there was only one place where you need to worry about how to generate an access key. And over time, how you made an access key started to become a little more complex, and you ended up with a situation like this. But with each individual change, it was sort of decided it wasn't that bad, right? Because it was just adding one parameter here to the method signature and an if test there. And it was quick and simple, and this abstraction already existed, so we had some sort of duty to honor it, right? Like, obviously it was here for a reason, so we can't just get rid of it. I mean, we can. But if instead, when we had been writing out that company code, if we instead had been willing to write some wet code, we write everything twice. And don't get too hung up on the number. You can write everything thrice and still adhere to the acronym. 4 is right out. But don't worry about too much about the number. It's just you're willing to accept some level of duplication in your system. Right? So when that other developer made the suggestion that, hey, let's abstract this out, the original author could have said that's a great suggestion. But I'm not comfortable yet knowing these things actually are the same. They sure look the same, but I don't know how they're going to change over time. And they could have made the call that I'm willing to accept a little duplication and say that, yes, users and companies are both going to be able to generate access keys, and they're going to look exactly the same. And as the requirements change, then how you generate a user access key can vary from a company access key freely, and they don't have to worry about each other. And this may still not be the best way to generate access keys for these two things, but it's a different way. And your ability to agree or disagree with any of these choices probably partially depends on your ability to predict the future. And I'm not great at that. So what I'm saying is this is hard to get right. It's also hard to know in the moment if you're doing it right. So when I'm interested in trying to get a sense of, do I really want to dry this up or not, I like to think of it in terms of flexibility. Both in terms of the flexibility you're gaining or losing in your system, and how much flexibility you do or don't need. There are certainly situations where parts of code definitionally should exactly work the same every time. And abstraction is a wonderful way to model that. Right? Definitely pull that out. Use it in the same place every time. It's great. Right? There are also situations where things just happen to look the same but aren't the same. It's an implementation detail. And it's subject to change over time, as all code is. And it may make your life a little more difficult to have then made that abstraction to then either keep and maintain it or get rid of it, because inertia is a hard force to work against. Doesn't mean you can't change it, right? We can totally back out of any of these changes. We've got to consider how we would do that, right? And make sure to keep that in mind when we're introducing any sort of changes to our system, whether it be for dry code or not. I have one last example to share with you today. We've merged that part of the code. Dark Dungeon customers have started to use our product. Everyone's super excited. But then we get a bug report from one of those Dark Dungeon customers. Say, hey, I passed in 15 in your API. I got one number. I passed it into Dark Dungeon's system. I got a different value, and I went off and did the math by hand, and I think Dark Dungeon is right. Could you take a look at this? Sure, I mean, that's our job. Before we take a look at it, let's talk a little bit about Performant Code. Right? I mentioned at orientation that Ivory Tower makes sure that all of their code is as performant as possible. And this part of the system is the core of their application. It's the entire business value that they offer to the world. So they need to make sure that it's right, and they need to make sure that it was fast. Right? Everyone the world over is going to be using this product, and it needed to fly. And Ruby's great and all, but they were kind of worried about it, so they wrote this part of the system in Rust. It's a systems language. It's obviously going to be faster, right? When I say we wrote it in Rust, I really mean Alice wrote it in Rust. And Alice is a wonderful and lovely developer, but she left for vacation yesterday for 2 weeks, and no one else in the company has written any Rust before. Now, there are obviously organizational issues at play here that is not part of this talk. But if that's the situation you're in, then somebody's got to figure it out. So we're willing to be a little adventurous. We've never looked at Rust before, but let's take a look. Right? We start rooting through the places we're familiar with, and we end up finding in our gem file there's this Helix thing that actually that's responsible for some interop between Ruby and Rust. So we have something to help us with this. Great, wonderful. And so we read the documentation on that, and through that we find out where the Rust file is. And so we see that we have some generate method or function. I don't know what Rust calls it. And I guess that takes some sort of hash or something. And then we point it to a vec around strings. I don't know. Maybe if you've done some Java before, you're thinking maybe this is kind of like the collections API. Maybe this is just like a list of things. I don't know. All right, cool. This is probably making a variable. I still have no idea what a vec is, but let's go with it. Awesome. Great, a for loop. I know what a for loop is. Feeling good now. Oh, bound. Bound shows up at the top. Right, so Rust is a strongly typed language, so bound is the name of the parameter you're passing into your method function thing. And I32 is a type of number. It's a 32-bit integer. Cool, so I'm feeling really good, right? So I'm going from 1 to some number plus 1 and iterating through that. Oh, no. Confidence lost. All right, so I'm calling some push behavior on that vec thing, and I'm passing to that the result of the match function, macro, method, keyword. I have no idea what match is. But it looks like that takes some math with the number that we're iterating through and then gets a closure or passes to a closure or I don't know, something. And then, okay, so we got a couple cases here, and then based on the case of that math, we get a number or a result back, and we pass that ultimately up through results. Great. You know, I forgot during orientation to say what Ivory Tower even does. They're one of the premier vendors in FBAAS. That's right, FizzBuzz is a service. They identified a core marketing need, which is developers the world over are constantly asked to write FizzBuzz, and none of us want to do it. So they said, you don't have to worry about it anymore. We'll take care of it for you. And moreover, you can now write FizzBuzz in any language you like. All you need to be able to do is make an HTTP call in that language. And so if you're familiar with FizzBuzz, you might be looking at this and going, well, this isn't a big deal. It's just this case here doesn't belong in the problem set. We can just delete it and the program works correct and you are right. If you aren't familiar with FizzBuzz, I'm not going to explain it to you. And congratulations. We're doing something right as an industry. One got through. And you don't have to know. You can just use Ivory Tower. But even though this change was easy to make and solve, it was a lot harder than it needed to be, right? Because we're all Rubyists here, and if we had just written this in Ruby, we would have been a little more familiar with the problem set and maybe could have sussed it out a little easier. But the reason it was written in Rust was because it was faster. But I don't know that this is faster, because I didn't benchmark it. And it could be the case that Rust is 70 times faster at fizzbuzzing than Ruby. Right? Or maybe Ruby is twice as fast as Rust, or maybe the difference is negligible. But Ivory Tower sure didn't figure out either. They just read something on Hacker News that says Rust is fast, so we're going to do Rust. Right? So Performant Code is great. Please, write code that's fast. It's wonderful. When you're doing so, making sure you're doing it for a reason. And also when you know that reason, because you have some data point that says this needs to be addressed, you can then use that data point to make sure that what you're doing actually does provide a performance benefit. Because I've certainly written code that I thought was more performant, and then ran the benchmark and realized I made it worse. Right? And if I just eyeballed it, I could have thought I solved the problem, but I sure didn't. And because they didn't have all this information, Ivory Tower doesn't know if they're in a better spot or not, but they sure have all the costs associated with it. Right? They now need to be experts in both Ruby and Rust. They need to make sure that they continue to work together. Right? They need to make sure to keep all the bits and pieces talking to one another. And again, that may have been totally warranted, but they didn't even bother to figure out if they needed it. So by all means, when you leave here, go back to your working profession or just your daily life, writing code, definitely make sure to make it work, make it right, and make it fast. When you're writing tests to make sure that it works, make sure you're doing it to give yourself the confidence in the change you're making, and so that the system is willing to, you're confident the system is going to work right, not just because some number on a screen tells you to do it. And best practices are great. They're the best. It's right in the name. So please use them. But the unfortunate truth is not all best practices apply equally in all situations. And the hard part is knowing when to use them. And as I said, definitely write performant code. I love using systems that are extremely performant. I sometimes like writing performant code. But when I do, I make sure it's for a reason, and I have a benchmark to tell me if I actually achieved my goal or not. But maybe that's just me and I don't trust myself very much. If you're interested in learning more about the NAR company, or you'd like a narrative description of this presentation, or want a copy of these slides, you can do so at the nar.co/RubyConf. I also have a Rails application on my personal GitHub account, which is Kevin-J-M. The repo is cleverly named Ivory-Tower. That Rails app has also a copy of the slides, a raw keynote file of the slides, and all of the code examples and some more that didn't make it in this presentation. I'm happy to take any questions afterwards on an individual basis. So come up and chat or see me throughout the rest of the conference. I have some stickers. They look like this. So if you want one or both of those, feel free to come on over and get a sticker. Otherwise, thank you all very much for your time. You've been a great audience. Enjoy the rest of your conference.